Oh, you guys, I really am very embarrassed. I've made a mistake about physics, and I have to tell you right away. Um, I first had the assignment that I wanted you guys to actually run upstairs to work against the force of gravity, which is downward, the force of gravity. And I changed the assignment, but I did not change the way we were analyzing it, and I really analyzed this incorrectly. So I want to thank, first of all, it was Rachel who made me see my confusion, and I want to apologize to you all. So you know that when I am running, there is a force pulling down on me, gravity, force of gravity, but that is not the same thing as the force that I'm expending to get me to go in that direction. Now, how would I find that force? Well, it turns out that all that force is pretty much expended in the first the first fraction of a second, because we know force equals mass times acceleration. And pretty much after about like a half a second, you're at a constant velocity. V equals constant. So what that means is acceleration equals 0. So in a sense, once you reach a constant speed, you have no more force that you're expending to get to that 100-meter point. So what we really need to do to calculate our power output is we have to look at the force times the distance pretty much in the first fraction of a second, because that's when we're accelerating. So it turns out, I did a little experiment, and it turns out that you do your accelerating pretty much in the first 1 second. We're going to do an approximate here. It's 1 second, and in that 1 second, you start from 0 speed, you go up, and you cover a distance or a displacement equal to 5 meters. So you start at 0 velocity, and then in 1 second you get up to 5 meters. So try to calculate your acceleration from that, and that will give you the force that you've expended to get up to that speed. And the distance in that case then is 5 meters. So that will enable you to calculate your power. Oh, shoot. That will enable you to calculate your work output. And once you have that, the power equals work over time. Now, I think I also said that I was going to ask you to calculate how much power are you expending in getting your car to the store. That's actually not as direct as one might think, and it doesn't involve gravity, because really the horizontal motion of the car is not the same thing as working against the force of gravity, working against this acceleration. This is, of course, the weight of the car. Okay, anyway, Pete and I are going to change places, and we'll try to get this straightened out, but I will send you an assignment. It was really fun today, and sorry about the confusion.